it was very difficult because it was from inception to procurement to installation to commissioning. And it is a landlocked country, and to get anything stuff in, we have to get it by air, where the flight was very minimum. So we had a very tough time in making it go online, and he said when it finally came, it came with a bang. He's the second CEO. I mean, one of his quote was, it's not that internet was not introduced because the government was suspicious, it's just because we were not aware what it could do. And his fear was that once we have it, it doesn't become a white elephant. Unfortunately, fortunately, it has not become a white elephant. It's a very good, useful elephant it has become. The topology in 1999, we just took it out from the intranet topology. We had 256 kbps uplink to British Telecom via satellite. We have the 3 POPs and a dial-up pool of, we numbered it 100, so that even those customers who are not connected to those POP, since we are a telco, we routed their calls through each of these POPs. So when you dial 100, you could get access to 33.6 kbps of your dial-up. We had 2 RIC servers. And this is the first picture of the Thimphu POP and where the mains are. You can see the border routers, all the core routers, the 2 IBM servers, the dial-up pool, the lease line. And this photo is courtesy of Philip Smith, who actually helped us set up the internet. And he's been helping since then. We call him a virtual family. Even now, I mean, he's been very helpful. He's been assisting us with the growth. So he's very much aware of what's happening in Bhutan, where we are heading. And Philip, thank you for your assistance. And this is the topology in 2002. We then connected to a second upstream provider, KDDI in Japan. So then we added another modem pool dial-up number called 101, whereby customer could access 56 kbps on dial-up. So 100 was identified with 33.6 kbps, 101 with your 56 kbps dial-up. So we added the topology is same. So these are, way back, these are the services we had. The tariff was quite high in 1999. If you see, it was Newton 2.5, and in 2006, it went as low as 0.17 Newton. The 64 kbps was almost $1,000 plus then. Now we don't have these services. We have discontinued 64 kbps. When we launched internet, one of the problems we faced then was we need to train our customers, people. So what we did was we took a lot of initiative in training our people. We had given free dial-up access during weekends to the schools so that the students and the teacher could use discounted tariff, and to very remote schools. When I say remote, it's about 3-4 days of physical walking. We provided them with free laptops and internet access so that the remote schools could access internet. These were some of the services we introduced. The reason of putting this slide up was one of, when we got connected, there were so many Bhutanese studying and outside. So one of the most famous sites they visited was the chat services, they were listening to home music, and the net pulse, all pen pulse and the net pulse, and e-cards. So these were some of the services which our folks who were not in the country used to access and send messages to people back home. In line with the awareness, what we did, we trained a lot of people in the Royal Institute of Management on how to use email, internet, basic web designing, and hands-on training. Because we had people, they took the service, but they couldn't use. So we had to carry on doing lots of awareness workshop, hands-on training. And one of the projects, training we did was to our district governors. Bhutan is divided into 20 districts. Each one is headed by a governor, equivalent to a governor. So they had come to attend the parliament session in Thimphu. So we invited them for a one-day session whereby we actually gave the top executive of the district how to use email and internet services. Then the other major one which we jointly took with UNDP was in Central Bhutan. The project duration was over 6 months, where the target audience were the students, farmers, businessmen, teachers, civil servants in that district, where we trained them on how to use Windows 95, 98, which are no more, Microsoft Excel, configuring and troubleshooting email and internet. We trained over 422 people. This number may look very small here, but in our perspective, it's a very huge number in that particular locality. So in 6 months, they actually used over 273,000 minutes of dial-up for this training. The other impact of internet was the telemedicine. We set up a small, in Central Bhutan, whereby the country was developing, so not every hospital had radiologists. So what we did together with IT was we set up a digitizer whereby the X-ray would be scanned and sent to Thimphu General Hospital in the capital, whereby the technician, the radiologist would see it over, and the detail, whatever treatment needs to be done would be conveyed by email or by phone to the remote hospital. So this proved to be very useful. One of the challenges we faced was the connectivity was on satellite. The transponder cost was very high, plus per Mbps was very high. We did not have any local contents, so every content has to be from outside. We didn't have skilled manpower and very nascent internet users in the country. The benefits was we also established what we call the multi-purpose community telecenter. As a pilot, we started in Central Bhutan, Pumtang, whereby even the phone lines were very limited. Not everybody could afford a phone line. So we have this something called MCT, whereby people could go and make calls, have an internet cafe, have fax services, photocopy machines. So these were some of the services that internet actually brought along in Bhutan. Now, when we introduce services, we are bound to have complaints. So some of the early complaints we were instructed then to have a proxy server, whereby we are supposed to filter out all the adult pornography sites. But what we did, we procured a box, a subscribe box from US, whereby they update the filters every night. But since all the traffic has to routed through this, it actually slowed down the internet and people started complaining. And the major problem was, since we have only one link, whenever British Telecom carried out plant maintenance, there used to be no internet in the country. So till they restore our services, the internet used to be out. And for our customer, we had introduced the night package for night users. So whenever we carried out late night maintenance, the night user used to complain, please do the maintenance during the day. And they were the minority users, but still then they used to make a lot of noises that whenever we carried out plant maintenance at night. So these were some of the complaints we used to receive. The other major one was the password leakage. It is still a problem, but it has minimized. Just to give a perspective, one of the agency, their bill came to about $250,000. That is close to about maybe $3,000-4,000 a month, because their password was shared by almost 1/3 of the population in Thimphu, internet user. And after we went back and told them, please change your password, their actual usage dropped from 250K to 40K. And the other one used to be, whenever we go to the field and set up internet dial-up, they would learn and they would play around, And by the time we reached office, they would call us saying it is not working. So when you visit the customer again, they would have deleted that, the desktop icon and all those things. So we again have to restart and help them. And one interesting one was, we had this particular customer who had a very old Windows system. So we went to his office, we set it up, it was working fine. And after a few days later, he wrote us a letter saying that his computer had actually crashed because we have set up internet on his computer, and he had asked for a replacement PC. So these were some of the early complaints we had. Even on online, we used to get complaints on, we used to extend support, but these are some of the complaints regarding your Hotmail account. And some of the popular services are we started this discussion forum whereby people could give their views to the government, to the service provider. And this was quite successful. And today, this actually gave birth to our national newspaper online discussion forum called Queensland Online. And the chat services are still very popular. And this is the topology in 2007, whereby we have actually expanded our point of presence, the services. We had 3 links, one to KTDI, one to British Telecom, and one to Hawaii. Actually, that was the antenna was almost 180 degrees because that was facing to a specific ocean towards Hawaii. So we had these 3 upstream connection. But with satellite, this is what we could do, the maximum. And the equipment room looked something like this, with proper racks and proper shelf cabling. Then we had this, then the government introduced the private players in on the internet services. We have, as of now, quite a number, but 4 major players out of 4, 3 are including BT. There are 3 who are the major players. And BT, of course, since we have these private operators, Philip Smith came, when he came visited, I said, oh, we need to have an IX, and the IX idea came up then. But then the government with the ministry, the ADB came up with a project called SASEC project, whereby they want to set up a regional IX at Siliguri, where then they want to connect Nepal, Bhutan, Bangladesh, and India would exchange local traffic among that with a subsea cable access. This was prior to us having a fiber access. We were in satellite, so we were quite happy. But this discussion took place in 2005, and it is still going on, the project. The satellite to fiber, we had our first access to fiber. We took an IPLC circuit to London, where we set up our own POP at London Internet Exchange, where we did peering and IP transit. It was a 45 Mbps circuit then. Today it's 2.5 Gbps, and we took peering from AbopNet. The second POP was established in Hong Kong with 155 Mbps. Again, we did peering with HKIX and IP transit from NTT. Today the bandwidth is 2.5. In total, we have about 5 plus Gbps. From 2007, if you see the growth from 2007, 45 Mbps till now, about 5 Gbps. So it's a very substantial growth. And very soon we'll be establishing our POP at Singapore Equinox data center. And this is the POPs we have today. We have about 80 plus POPs throughout the country. Even the remotest part of the country has point of presence. And this is the network today. What we have got POP at London, Hong Kong. We have a circuit with India for the Indian traffic, but a few months ago, we terminated this circuit. So this is the network topology from the single link to British Telecom way back in 1999. This is what we are today. And internet is one part. Now we also need to provide the access. So access has been all copper till few years back. For last three years, we have been extensively deploying the fiber to the curb, fiber to the home, fiber to the building. Fiber to the home, we tried as a pilot project to connecting in Thimphu about 30 homes, but there are not many takers because the fiber CP was too costly. It's about close to $150 to $200 per CP. So because of that, the uptake was not that much. But we have 30 homes connected on fiber to the home. But fiber to the building and fiber to the curb has been extensively deployed because once you have this reliable last mile connection to the home, the internet usage improves. And we also have plans to deploy video content, IPTV maybe, video streaming soon. And with the internet being quite stable, for the next thing what we did was we established a Tier 3 data center in Thinley, which was inaugurated last month by our Prime Minister. The whole idea was to cater to the need of the country because data has become so critical and we need a proper storage, a proper place where the data could be kept in all good conditions. We are, this is for our own requirement and also for looking beyond the geographical boundaries of Bhutan, maybe to our neighbors. And that's all I have. Thank you very much.
Thank you, Jichen. Can you take several questions, if any?
If there are questions, sure. If there are no questions, that also is fine.
If not, then thank you, Jichen. So next up is Cody. He will talking about the international network market. Wow.
Look at the. Sure. So yeah, we have a couple minutes here to change slides. Yeah, my name is Cody Williams. I work at TeleGeography. I've been there about 5 years now. I cover the Asian markets, and I work on 3 products for us. I work on our voice product, which we're still doing. That's what we started out with. People are still interested in voice. I know people are sometimes surprised by that, but it's still there. Also work on our global internet geography product, which covers public IP space. Then our global bandwidth research service, which covers has profiles of submarine cables, developments there, tracks a combination of public IP, private networks, and then also the voice traffic that's lumped into that. So that's less than 1% or so. Yeah, and today I'm going to be talking about convergence between Asia and Europe, both in pricing and capacity. So first off, typically when I'm speaking, I do an overview, if you guys have seen me before. I'm not going to do that today. I'm doing a more specific question. If you want more of an overview presentation, we actually did a really huge one at PTC on Asia, and that's on our website. So if you want to access that, just send me an email or something. It's in our insider section. I've actually got several comments already about my colleague Tim's discussion at NANOG in Baltimore, which went over really well. And I have to say that I won't be presenting as a robot as he did there. He's a much better presenter than I am at times. I'll try to talk slowly. I understand. Please bear with me. I get very excited talking about this stuff when I get put out into the real world. So if I start talking too fast, just tell me to slow down. I know I've got a gravelly thing going on here from a cold also. So I'll take no offense if you tell me to slow down when I'm speaking. Everything I'm talking about here are international networks. When I refer to internet, I'm referring to public IP traffic and bandwidth. Bandwidth prices, when transport stuff, we're all talking about pop to pop. And then on IPT, we're talking about ports. There's not a whole lot of restrictions, though. We do get into some restrictions. For example, at Hong Kong can be all China mainland traffic and things like that. But for the most part, all those are interchangeable. So what do I mean by convergence? And the first stop on anything when you're researching is going to Wikipedia, right, and seeing all the possible answers here. These kind of all sort of fit. The closest one's the economics. But what we're really talking about is just everything converging to a single number. So everything capacity-wise growing to the same level of capacity and the prices falling to the same level. Now we move to this unified number. So again, what we're talking about are wavelength and IPT prices. Are they becoming one? So essentially, is Asia falling fast enough to meet the floor of Europe? And on capacity, are Asian levels growing fast enough to kind of catch up with Europe? Because Europe, historically, Europe was cheaper and Europe had more bandwidth, right? So but we've got a lot more places in Asia that are coming online and growing much quicker than for example, Western Europe. Now, what can cause this? Now, first off, excuse me. Here we go. So what can cause price differences? A very simple thing is competition or lack thereof, right? So on some things like transpac routes and transatlantic routes, you've got a lot of cables, you've got a lot of people on it. If you're selling bandwidth, it's somewhat commoditized. There's differences in landing points and things like that, but typically the backhaul costs on both sides are not so high that if you land in Paris versus London, it's a problem. The same with landing in New York versus somewhere else in the US. Supply, again, so on those two routes we're talking about, transpac and transatlantic, there are a lot of cables, right? That's not necessarily the case. Like if you need capacity off the west coast of Australia, you've got CME-3 and that's it. And there are other unique cables in that situation. In Southeast Asia, we've got a lot of countries that have one cable connecting it. Or in the case of Cambodia, there's no cable right now, but one's coming. Chonwei is landing a spur. But right now it's all terrestrial. And another thing is distance. So this actually comes up quite a bit when we talk about price differences because if you looked at the numbers of what it costs, and prices to build cables have kind of all come down over the past 20 years, right? But if you need to build a transpac system, which is much longer, you need more equipment and more time to lay it and everything. So it'd be more expensive. We kind of find in practice it's actually less of a factor than you think because all the price of the capacity is done on incremental cost and upgrade cost, not necessarily construction costs. And kind of a second point to this is when we look at somewhere like transatlantic, all that stuff was really expensive to build and pretty much all went through bankruptcy and reemerged with new owners, which paid a lot less for the systems than they initially built. Trans-Pacific, we have that with PC1 that went through bankruptcy and then emerged and then was bought by NTT. But most of the other systems have been paid for what they were cost. Some of these, like Southern Cross, for example, has been paid off for quite a while. A lot of the other ones are still in the process of being paid for. And network configuration. So we talk about express fibers, multiple segments, and things like that. Pricing actually comes into this quite a bit because if you have a bunch of equipment you have to replace to do an upgrade, the card costs go up and then your upgrade costs go up. We have an express system or something that where you've configured it to where you don't have a lot of stops. The upgrade costs are a lot less, and therefore a lot of times that cost of upgrade is passed on to the customers in lower prices. Now there's two ways to look at this, right? So again, on capacity, is capacity growing fast enough to approach these historically higher European levels? And this is even as European capacity continues to rise, right? So keep in mind this entire time, Europe is not being static in contrast to Asia. It's still growing in capacity and the prices are still falling. And conversely, on the pricing side, are the price declines aggressive enough to be catching up with Europe even as Europe continues to decline? Because I think everyone that's been involved in Asia the past couple of years has known that there's been pretty steep price declines on a lot of the big routes. Now let's look back a little bit here. So this is global capacity in 2004. The little lines look very tiny on here in comparison to this next chart. But to give you some actual numbers here, so everything is in GBPS. But if you're looking at the transpac is 178 gigs in 2004. Transatlantic is 530 gigs. We've got some other really small numbers. The biggest number for this is actually intra-Europe, which is at this point 1.4 terabits or so. Intra-Asia was quite low at 98 gigs. We saw in the past 10 years a lot of cable growths, a lot of new systems and things connecting intra-Asia. Now, in 2014, these lines look a whole lot fatter, right? Not too surprising. Internet's grown a whole bunch in the past 10 years. Looking at transpac, it's now 10.2 terabits. Latin America has actually been the craziest one. So if you look here, this little tiny line, 77 gigs or so. Now it's 12.2 gigs. Well, one too far. I will say, kind of maybe a little bit outside the scope of this, but an interesting thing, since we talk a lot about peering here, the U.S. Latin America has had a ton of growth because no one traditionally has peered within Latin America itself. So a lot of this traffic actually trombones up to Miami and Napa, the Americas, and other places, and goes back down, even though theoretically they could interchange it in Latin America. We'll see if this changes. I think because the past couple years thought there wasn't going to be much change, but with Google coming out in Brazil and a couple other new data centers, there's more places to actually interchange traffic. So we'll see if everything changes there. And going back to 2014 here, we're looking at 8 terabits now from Europe to Asia. It's been a huge amount of growth there, a lot of new systems the past 10 years. Also looking at US and Europe, we've got 10.7 terabits. Now let's look at it at a country level. Now I will say, keep in mind that this comparison is not perfect because European and Asian countries are very different. These 6 all kind of act as hubs in some way, but there's other things going on. But also there's kind of a caveat there in that European countries tend to be smaller and interconnected with more. Asia is much wider in comparison. But growth rates here, so a lot of times we'll actually like to show 5-year annualized growth rates just because, this is a base 10, base 64 networks and everything, so upgrades can be very lumpy. And so if you look at 1 year, you're going to have crazy growth 1 year, no growth the next year because people provision a network. And you can't necessarily provision, the 1 gig you need to do 10 or 100 or a terabit or whatever. So looking at 5-year growth rates, we see kind of the trend of these Asian countries growing a little bit quicker than European countries, although Japan's a little on the same range as France. Looking at the UK, we've got just a little under 34% annualized growth over the past 5 years. Germany, a little over 37. France, a little under 37. Japan, again, a little over 37. So all 3 of those are kind of within half a point of 37 there. China, which also includes Hong Kong in this, is growing at 47.6%. Then Singapore has been the fastest at 49%. Not surprising since Singapore has become such a huge hub for everything in Asia. And also since, Singapore has become a big hub, all these guys are hubs, but a big thing has been all the growth we've seen in Southeast Asia and a lot of new countries coming online on these systems that are all connecting through there. And a big part of this is as everything is cached and rolled out closer to the end of the network, I've actually had a lot of carriers tell me that they've quit actually coming from maybe Southeast Asia to the US because they can pick up all the content in Singapore now. So instead of having those big expensive transpac, intra-Asia and transpac links, they have smaller links just to Singapore. Because there's a good chance you can pick it up in Singapore, and if you can't pick it up in Singapore, you can pick it up in Hong Kong. You don't necessarily need to come all the way across anymore. Now looking at this as a multiple, because this is really what we're getting at, right? So in comparing these 3 countries to Germany, how has the bandwidth played out? So in China, there was 5.3 times more bandwidth in Germany than in China in 2010. And it's actually down to 4 times the amount in 2014. So still, there's a ton more bandwidth in Germany. It's not to be expected as big as Frankfurt is and everything. But that number's actually dropped pretty significantly, I think, 5.3 to 4. Kind of, since we looked at this chart here, and you saw Japan's been kind of in line with a lot of these other countries here. As a multiple, it's been about the same. So it's 6.5 and then 6.45. So 6.5 in 2010 and 6.45 in 2014. They've been relatively constant in terms of comparing Japan to Germany. Excuse me. And not surprisingly, Singapore has had the most convergence of the 3. We saw Singapore's been growing the fastest of these 6 countries. But if we look at 2010, Germany had 11.8 times more bandwidth than Singapore, and now it only has 8.5 times more bandwidth than Singapore. So in comparison, Singapore is quite small in comparison to Japan and China, but still there's been a lot more growth there. So we're seeing a little bit of convergence there. So what's kind of our conclusion on that then? Is that, well, we're seeing a little bit of convergence, right, with 2 of these countries, China and Singapore, not so much in Japan. But that's coming from 2010 to 2014, right? We still have the future in front of us and everything. So we look at projections right now until 2021 in our Global Bandwidth Forecast Service. We're looking at bandwidth growth for Asia is 40%, and in Europe it's 36%. So we'll continue to see a little bit of convergence out towards 2021. But even with that said, we're looking at, if we actually look at the multiple of Asia versus Europe, right now it's about 3.55 as a total, and in 2021 we're looking at about 2.9. So yes, we're seeing a little bit of convergence as far as bandwidth goes, but no one should expect Europe and Asia to be the same number, even in our forecast this far in the future. Now let's look a little bit about pricing. So we kind of come to the conclusion that there's a little bit of convergence as far as capacity goes. Europe is still going to be bigger than Asia, even in our future, even in our forecasts. What about pricing? And this is either the great or the scary one, depending on how you're in the market, right? So if you're a seller, you've had these incredible price declines the past couple of years. And the idea of it being European levels and things like, well under $10,000 waves on transatlantic and things like that. It sounds really scary if you're selling the Transpac, right? If you're a buyer, it sounds really awesome, though. So kind of luckily, as a researcher, I don't have a dog in the fight. So my condolences to sellers and congratulations to buyers, basically, as far as this price declines the past couple of years. Now, we know worldwide prices have been going down everywhere, right? There's one trend in prices and that they go down. There's not much hope of prices stabilizing or going up. It's just a matter of, can the price declines be offset by increases in capacity, right? So that was in Asia In Asia for a long time, what was happening is price declines were offset by capacity increases. So even though you sold more capacity and year X than you did the year before, you still made the same or the more amount of money. We had these huge price declines starting a couple of years ago. The problem was you were selling more and making less money, which is not a very tenable position to be in. So we actually saw a lot of the smaller carriers that were maybe buying extra capacity from what they personally needed as a company and doing like bulk breaking kind of things. It seems like several of those have actually moved out of that kind of market and are now just buying for their own capacity needs. Winter prices have been going down. Transatlantic's been cheaper than Transpac, sometimes by a lot. Again, there's other reasons for that. Although systems that went through bankruptcy and meant the cost basis is very different. The systems that were built in Transpac were built, some of them a little bit later. There's the distance thing as far as cost and all that, isn't as big of a factor. But with all this thing, are we moving towards a unified price between the two, with all those things considered? And here we go, here's some median monthly prices for 10 gig wavelengths, and I've picked 4 out here as a representative. I went past one slide, didn't I? Okay. It's a very sensitive button on here. So we've got 4 wavelengths we're looking at, right? So we've got London, New York, which is the big transatlantic route. It's the number 4 route in the world, according to our research. We also have the inter-European route of London to Amsterdam. A lot of data center traffic between the two there. That's the biggest route in the world, according to our research. Then for Asia, we have 2 routes. We got Singapore-Tokyo, it's a big inter-Asia route. Then we have Los Angeles-Tokyo, which is a big Transpac route, which is the 15th largest route in the world. And so each of these, we're kind of in the assumption that they're large and competitive. There's a lot of systems here, a lot of carriers that can offer it. Wavelengths-wise, it's pretty commoditized, especially when we're looking at these specific ones when we're all landing in the same place. You can all get to wherever you need to get in LA from these. Same thing as far as Tokyo and all those others. So, and I should say that on some of these, we've seen some pretty incredible price declines too, right? So these all should be good examples as far as ones that have been trending extremely downward. So examining these, and we have a problem of scale on this figure too. I actually wanted to add some other routes to this, but the problem is when you start adding the ones that started at 150K in Q4 2010, then everything gets smushed down, right? So even now, these 4, if you look at the 2 Asia routes in LA, Tokyo, and Singapore, Tokyo, it looks like there's a lot more decline there than we see on the the transatlantic routes. But the reality is, if we took those out and scaled it, these transatlantic routes have been falling quite a bit. It's just that when I tend to graph these, since they're so small, it looks like the change is actually small when it's not. But actual numbers here. So, and these are all median prices too. So some of you guys in this room are big buyers of bandwidth and can get well below these prices depending on who you are. But we have for all this, we do a pricing scenario. So it's pop to pop, 10 gig wave, one-time buyer, and then the median prices of the range we get from carriers. And so looking at this, so Singapore, Tokyo started out the highest at $78,500 in Q4 2010 for 10 gig wave. Now we've got our median price at the end of the year last year at $20,000. If we look at LA, Tokyo, we started out at $65K in 2010. We're down to $16K now. And I remember this is, I started in 2010 at TeleGeography, so this is my direct timeline when I've seen prices come down. I remember someone telling me on LA Tokyo about a 50K price, and that being like the superhero price since I was working. Because there are a lot of ways we think of pricing. So these are all median, right? So we also think of the low price. We think of the hero price, as a coworker calls it, for that crazy one-time buy of, it's one that had to have that customer willing to sell it to him for nothing. And 50K was that number when I started, it seemed like. And now, if you can sell 50K wavelength for Transpac, you can probably sell anything in the world, right? But looking at these, if we look at the transatlantic guys here, so London, New York started out at 11,275. Now we're looking at 7.7K for the median, slower than the low side, of course. And for Amsterdam, London, the intra-Europe route, we looked about 5.6K starting in Q4 2010. And we're a little under 2K now, 1.9K for our median price. Now let's do this as a multiple also. And so we're going to compare these two, the LA Tokyo and the Singapore Tokyo route, over the London New York route, so to the transatlantic route. And what we see clearly is this is trended down, right? So we're getting some pricing convergence here. We started out, the Singapore Tokyo route was 5.6 times as expensive as transatlantic. Ended up at 2.75 over here at Q4 2010. And if we examine LA Tokyo, it started out 4.6 and actually ended up at 2.2 times. So we are seeing some pricing convergence here in bandwidth, right? Still, 2.2 is more than twice as expensive as transatlantic, but definitely a downward price trend. So these are all bandwidth prices, right, which tend to be the first fallers. Bandwidth prices tend to fall, pricing in general tends to fall from bandwidth kind of down through other products. So bandwidth to an IP and then other managed products, enterprise products, things like that. So let's actually take a look down and see what it looks like on IP transit pricing, right? Again, everything's falling all over the world, right? So again, if you're a seller, I'm sorry. I hope everything is okay. If you're a buyer, it's been a good time to buy, right? We're looking at these routes here. So Hong Kong, we've got the six routes that we showed IP growth in, all on here pricing-wise. So like Hong Kong, we started out at 17, we ended up at 5.75. Singapore, similar, started at 18, ended at 5.5. Tokyo was the highest at 25 and actually ended at 6, so it came down to the level of other, IPT came down to the level of Hong Kong and Singapore almost. Frankfurt started out at 4.36 and is now, our median price is a little over $1. You can get less than that on the low end for sure. London and Paris both started out at 4.5 and both ended up 1.3 and 1.2 respectively for our median prices. And again, this is another chart that due to scale kind of distorts how much European prices have fallen just because the Asian prices started out so high. But it looks cool and dramatic this way too. So we know everything is falling, right? That's we see some pretty big price declines here. In absolute terms, going from 4.5 in London to 1.3 is not maybe a whole bunch of money, but percentage-wise, that's actually a ton. It feels much better if you're buying Tokyo at 25 and now you're buying at 6, right? The $19 difference per meg. But if we look at it as a multiple, we've seen it be relatively constant, and so we haven't seen the pricing convergence on the IP transit that we've seen in bandwidth. So we've got the height here, or for Tokyo was a 8-to-1 over Frankfurt in Q4 2011. Now, if we started out, Hong Kong started out at 3.8. Singapore started at 4.1. Tokyo actually started at 5.7, and the pricing as a multiple jumped up, even though everything we saw declined, right? The pricing as a multiple jump because Frankfurt was falling faster in relation to Tokyo in 2011. Of course, this evened out as that price came down. We see in 2012, the multiple came back down. But we're ending up a Hong Kong at 4.95, Singapore a little over 5, and same with Tokyo. So pricing, if we start the beginning and the end, has both been in the 4 to 5 range. So we haven't seen IPT pricing convergence. Now, why aren't they converging? Well, there's one thing is they're very different products, right? Wavelength's more commoditized. Sometimes you're spending more on IPT because of who you're buying it from, who they can connect to. There's the idea that it's just different sellers in different markets. the cheap guy selling bandwidth isn't necessarily a guy who's in the IPT market at all. And backhaul and cross connects can be a very expensive pain. So a lot of times, if you have to get somewhere with IPT, there's other things involved in it, necessarily the pop-to-pop that we're seeing on bandwidth. So we've got good news for some. So Asia is getting cheaper compared to Europe. Again, depending on who you are, that's a bad thing, a seller, or a good thing as a buyer. But what about the future? We expect prices to continue to decline, but there will be no single unified price going to happen anytime soon. So kind of we've seen the pricing, we've seen a little bit of capacity convergence. We've seen some pricing convergence on the bandwidth side, transport side, but we haven't really seen it on the IP transit side. We expect these things, everything will continue to go down and move a little bit, but for good or for bad, we don't expect there to be this single unified price for any time soon in our forecasts. This is my contact information. Feel free to send me an email if you'd like any more information. Of course, these slides are up and everything too. But that's all I have right now. You have any questions? Of course, I can answer questions kind of outside the realm of this too if you have any other questions we tend to cover on research. Gaurav is first up.
Yeah.
You're not shy, I know that.
Yes. Good morning. I'm Gaurav Padar from Limelight. You kind of left out the Pacific in this completely. Do you have any data point or something you can point out? I mean, yesterday at Apops, everybody was talking about Pacific, so I was wondering if you have any of this data that connects with the Pacific Islands or Australia, New Zealand. And
Do you have any in general?
well, I mean, it's too late to put it on the slide.
Yeah.
So, yeah.
Yeah, and we cover all those I didn't hear the first part of your question. I can't hear the microphone very well.
Oh, I just was pointing out that, you know, if you have anything in general about the Pacific, which I think is missing here, given that this Apricot,
Yeah.
and, you know, bit about Pacific would be nice. Being on the PC, I probably should have told that to you earlier. But even now, it's not too late if you have something to add to it. Thanks.
Yeah, we do, and so Oceania tends to be a different market because it's kind of two things there, right? So we've got Oceania is kind of greater as Australia, New Zealand itself. Then also you have a lot of disparate countries kind of thrown out through there, like Solomon Islands, other places that have spurs to them. It tends to be much more expensive than Europe, or excuse me, much more expensive than kind of mainland Asia, if you will. There's a handful of systems. There's been more talk there as far as new systems than anywhere else. We still have a lot of proposed cables. The 3 APX cables, for example, connecting the West Coast, which only is served by CME3 right now, which, as some of you may know, was out, I think, between 4 and 6 months last year. They cut off the Indonesian coast. They're looking at putting in another submarine system across Australia and then another West Coast to connect to the U.S. Hawaii Cable is another one that's looking at the West Coast there. So kind of on that front, we've got, there's others too, the Latent Cable and some others, ASC, that have been proposed through there. There seems to be a lot of interest in what's going on. As far as a lot of the island connections, I know there's been a couple. Do you have more clarification you'd like on that, or?
Are you seeing any kind of convergence you are seeing on the rest of Asia in the Oceania area?
Am I seeing what?
Any kind of convergence in pricing?
I'm not sure offhand, honestly. Pricing has come down tremendously through there. I know Southern Cross has cut prices several times. Their advertised pricing has come down quite a bit. The problem that they run into, obviously, is that everybody is so isolated in Oceania that there's not the market that we see as far as like for Transpac and things like that, where you don't have a half dozen systems carrying capacity that are competing with each other and things like that. As far as actual convergence there, I can't say enough offhand to really tell you anything. That's something, I don't know if I could put something together and we could add it to these slides, ex post, put it on the Apricot side, something like that.
Thank you.
Any other questions? If you have any other ones, feel free to email me. As always, I know some people don't like to get up and actually ask questions, but I'm always available if you need anything. Thank you.
Okay, thank you. So next up is Nat. He will talking about Anycast, but only limited.
Unlimited scale, yeah. What do I press? Is it? This one?
Forward, back, and laser point.
Okay, cool. Okay, thanks. Hi, I'm Nat. I'd like to apologise if anyone's seen this talk before in the last 9 months. Hopefully this will be the last time I give it. So I'm going to talk to you about an Anycast project that I embarked on in October 2013. A little bit about myself. I live in the UK with my wife Claire and our little dog Toby. I work at Cumulus Networks. We provide a Linux operating system that runs on switches. And this was a project that I embarked on in my spare time. I'm also on the board of UK NOF, which is the UK Network Operators Forum. We organise a conference three times a year. A little bit of an introduction to Anycast. It's a super simple concept, but it's increased the performance of the internet greatly in the past few years. You announce the same address space from multiple locations, and users will typically go to the closest node that's announcing that space. So for things like K-route, where they used to have a single instance at links in London, now they have multiple instances around the world, and performance has increased. So the benefits to this is load balancing, increased performance, and you can localize the impact of DOS attacks. So I was super interested in Anycast, and I really wanted to have a go at deploying it. And I was motivated by 2 presentations that I'd seen at events. The first off was one by Bill Woodcock from PCH, and this was at Sano Gate. I hadn't been to the event, I'd just seen the slides. And this was best practices in Anycast service provision. And the second was a Dave Knight presentation about how to do dense deployment of Anycast and do it on an automated basis. And I also wanted to gain a lot more experience of managing and automating distributed systems. So my thoughts were, can I do this without spending too much money? And this was like a pet project at home. And I wondered what I could offer. So I considered offering a secondary DNS service. So this was a slave service, not a resolver at all, just a secondary DNS service with IPv4 and v6. And I was going to offer it for free with no SLA, and I wasn't going to charge anything. And most importantly, did my wife Claire need to find out? So the tolerance level of that was I thought I could get away with $1,000 a year as the running cost, and that had to include everything. Anything above that, and it was going to get on her radar, and I'd get in trouble. So the requirements for this was I already had a small AS that I ran myself, 30746, and I had a spare /24 and a spare /48 of space from a previous project. So I looked on the right website and found a friendly LIR. I paid them €50 and I got a new ASN 60564. And then started writing out the things I need to build the service, and one of them was a super automated way of deploying all the nodes. And I wanted to play around with new tools and lots of these DevOps toolkits that are appearing now. And also wanted to give away everything that I've written, so I put it all on GitHub. So what did the network look like? There was no backbone or global infrastructure. There was just a whole bunch of separate nodes, and I announced the same address space from each of the locations. So I have a /24 of IPv4 space that I announced /48. And the thing I started doing recently is also announcing a second v6/48 from every location. I think right with their RIS service refer to this as an anchor prefix. And I started doing it to debug v6 problems with some of the locations where I was hosting equipment. So I announced 3 prefixes. Typically I get a /30 from the provider between my node and their router. I don't accept any routes from them. I just set my default gateway on my Linux box to their router. To manage the network, I was using, for the management infrastructure, I had some message queues and stuff. And I didn't want to have to get into running SSL and stuff for my management network. So what I did was I built an OpenVPN tunnels back to a management node. And when the boxes start up, they just open an OpenVPN connection back. And over those tunnels, I have some RFC 1918 space that I do the management over. And this means that I can instantly protect all the zone transfers that are going from the management box out to the outside nodes. Oops. How did the DNS side of everything work? Well, in my management network on the left here, I have a box called axfr.esgob.com, And that's the sort of a transfer location. So people whose zones I host, they send zone transfers to that box. And from there, I do the transfers out to all the Anycast locations. And that means I can very quickly add additional Anycast locations without having to tell everybody about the new management IPs that they need to transfer their zones to. I also support notifies. So someone could send a notify to the transfer box, and it would in turn send notifies on to all the Anycast locations. And all this happens over the top of that OpenVPN tunnels. So I started building up this little proof of concept on some VMs on my laptop, and everything was working. And then I wondered, how am I going to store the metadata about the locations of the servers and the DNS zones? So I considered things like MySQL or Postgres, but I wanted to try something new, so I had a look at these NoSQL databases. So the one that I was excited about was RethinkDB, and this is a distributed JSON document store. And it made life super easy to add new attributes because I could just add the data I wanted into the JSON and post it back into RethinkDB. So I have some examples here on the left-hand side. I have 2 zones that are declared, and I store the zone name and the source IP where I take the zone transfer from. And on the right-hand side, there's some JSON that describes one of the Anycast locations. So I'll show you on the laser pointer. This is a box in Edinburgh. So I store the location of the server, the geo-lat and long, so I can put it on a map. Some peers details here of how I set up the BGP sessions. So if I want to store any future data about a node, I can just add a JSON attribute in here. It makes it super easy. I then started coding up some Python to string it all together. And I wanted to make it pretty loosely coupled. One thing I'd found when looking at other DNS services and speaking to people at conferences was a lot of these existing DNS infrastructure is based around cron jobs or on possibly rsync. To get the zones out to the edge, a lot of people would just rsync the zones, and then with a cron job, they do RNDC reload. And I thought that was a bit, it was like something from the 90s, and I wanted to be able to have instant updates. So what I've ended up doing is have my database on the left here, a REST API, and as users either go onto the website or they use the REST API themselves, I put a job into Beanstalk, which is a message queue, and then running on all the Anycast nodes, I have a daemon, and this daemon listens for messages that come into the queue, and it instantly updates the configuration on the Anycast nodes themselves and hooks the daemon. So someone can go to the website or using the API and add a zone, and then within 5 to 10 seconds, the zone is live on all the Anycast edge locations. So I built this all out in VMs, and then I had to kind of think about where was I going to host these Anycast nodes that had to fit within the budget. So this my price point of $1,000 a year running cost, it ruled out any co-located boxes or dedicated servers because they were instantly above that price. I needed a super wide reach, and then I considered virtual machines, and maybe I could swap them with friends, or I also was looking at low-cost hardware. So I started looking for VMs online, and I came across a company called Mythic Beasts in the UK, and for £7 a month or £84 a year, about $141, I could get a VM, and this was 512 meg of RAM, a single CPU, 10 gig of disk, 75 gig of bandwidth. So without really thinking that I was going to need a BGP session, I bought it and put it on the credit card and had the VM. I knew they were kind of a Linux-orientated company, so I bought the VM, and then I opened a support ticket and just asked them if I could have a BGP session. So I just wrote in an email, I've got a /24 and a /48. Can you set me up a BGP session? And I was super excited to get an email back a few minutes later saying, yep, we're here with these IPs and the session's ready. So I'd got my one location up for the $141 a year. I then needed to find out where I could get more VMs for not spending much money, but they also had this critical BGP session I needed to do the Anycast. So one website that I came across was lowendbox.com, and this is a forum and a message board where the criteria is all the VMs that are listed on there have to cost less than $10 a month. One thing that I had a problem with was these were mostly OpenVZ based, so these were C group containers, and when people typically configure them, they don't allow you to have a separate routing process in the container from the hypervisor. So I was looking for folk that were hosting on KVM, Zen, or VMware because I needed to run my own Quagga and Bird instance. The other place I started to find people that were selling cheap VMs was on Low-End Talk. That's another forum where people list cheap VMs. And the critical keywords on Google for finding these folk is VPS BGP session. I found a few folk that had already got a product around VMs with BGP sessions. My second VM was actually in Detroit. I saw them listed on Low-End Talk, and this time I was going to be a bit more cautious. So before buying the VM, I emailed them to ask if I could have a BGP session. They said I could on any VPS. So for $80 a year, I got my next VM, a similar spec to the first one. This is the order that came through, and it was $80 for the whole year. It included a full table BGP session. I thought that was great. I didn't think at this point that I was going to find anything cheaper than that. So then I kept monitoring this lowendtalk.com, and I saw an Indian company in Pune that they were offering VPSs for $120 a year. I thought maybe I could stretch to that. So I started filling out the form. I'd already emailed them to find out if I could have a BGP session. And then suddenly on Low-End Talk, they posted this offer where they had this promotional code that offered a $72 a year reoccurring discount. So suddenly I had another VPS for $48 a year, and this was in India. And this was kind of the price of like some of our shopping, the grocery shopping the week. And I've managed to get a VPS in India with a full table BGP, V4 and V6. And looking back, when I started off messing around with BGP in the late 90s, I had a PSINet 64K circuit to my flat for selling domain names on. And at the time, I had to pay $1,500 BGP turnip fee. And now the annual recurring fee was $48 a year to have the BGP session and the CPU and everything to go with it, which I thought was kind of awesome. By a couple of, maybe about 4 weeks in, I'd got 4 VMs up, 2 in London, 1 on an existing KVM box, the one with Mythic Beasts, and those 2 others that I found. And it was super easy to spin up a VM. I just made a JSON entry in Rethink, installed Debian, installed Puppet, and then it was done. And then I went to the pub, and the new Anycast node was live. And then people started asking about what I was up to with Anycast, and I then had some offers from friends. My friend Charlie at Fluency and some friends in Boston had offered me VMs. And then randomly, someone had been looking on bgp.he.net and seen that I was spinning up these new sessions around the place, and he offered, Simon from Fremax in Germany offered to swap a location with me. So after a month, I had 7 locations up and running. And then lots of other friends would offer to host a VM, but the problem with this was that they were often network engineers and didn't have access to the VM hosting infrastructure in their organization. So I wanted to try and find out some kind of low-cost hardware that I could send out. Or the problem is maybe that they had access to the VM infrastructure, but they had a layer-free switch in the way between the VM hosting infrastructure and the backbone, and that layer-free switch maybe didn't do BGP. So the solution in this case was a Raspberry Pi for $35. I bought a few of these to start running as Anycast nodes. They were 800 megahertz overclocked, 512 mega RAM, and I put a 16 gig SSD in there. I sent a Raspberry Pi to my friend David in Belfast, and NSD3 was running great on there. I was getting about 200 queries a second on there. But the problem I found with NSD3 was that to add new zones, I needed to restart the daemon completely, and that would take the service down. So I quickly swapped. I was sat in a hotel room, and I swapped everything out to Power DNS, and this was quite easy because I just updated my Ginger templates and Puppet, and Power DNS went out. But then I hit a bug with Power DNS that on ARM, it would segfault. So then I quickly had to back out that change, and I just thought I'd go for the easy option and send bind out everywhere. And it got to January, and my friend Matt was working on an internet exchange, Matt Peterson, called SF Mix in San Francisco, and he offered me a port on the IX. But the problem was that he said I couldn't have any rack space, because if I had rack space, he had to charge me. So I have this 0U install, which is actually installed down the side of the rack rail between the edge of the cabinet and the rail. And this is a FIT PC2i, and it's a 1.6 gigahertz Atom with a gig of RAM, 16 gig SSD, and I got it for $150 on eBay. The first time I gave this talk at DNSOARC, some of the people in the room I was actually pairing with, like ISC and HEANet, and they were actually surprised that they were pairing with this box that was hidden down the side of the rack rail. I then started having some problems with that original Pi that I deployed. it was pretty slow because it was a single core ARM. So I started looking at other hardware. So I found some cheap gigabit bricks boxes, which were quad-core x86, 4 gig of RAM and a mSATA. So I swapped out the Pi. And then my friend Andy from Allegro, who's here, I sent him a box to host in Manchester. So often people would just put the box on top of their switches in their POP. This was some Metro Ethernet switches in a cabinet. As of today, I got to 25 nodes live and appearing in 3 locations in San Francisco, at the RIX exchange in Reykjavik in Iceland, this Ulyanovsk exchange in Russia that I've got no idea where it really is. They just sent me login details to a VM that had 2 NICs, one facing the IX and another with some transit on it. I still don't have great coverage in APAC. But I'm currently hosting for free about 30,000 domain names. People just seem to sign up online and use the API. The barrier to entry at the moment, I don't have a web interface, so you have to know how to use curl or be able to add your zones. So I had a lot of fun along the way of building this over the last year. I was often the first BGP customer for some of the VM hosts, and sometimes this took a bit of education. A lot of people would prefer their transit routes over the routes they'd learned from their customers, and this meant I saw a lot of doglegging, especially when my VM went down, they'd still be announcing the routes. And what I found was super scary is that people would set the BGP session up, but with no route filters. So I could announce any prefix, and they just announce it straight onto their upstreams, which is really bad for the health of the internet. So in some cases, I'd help people, and there was a couple of the folk that I've got boxes with, they give me SSH logins, and I'd set up their communities or tell them how to set up some route maps. The one that would get me on a lot of occasions was they just announced my prefixes, and I'd had no control over where they announced to upstream. So I'd sometimes show people how to use communities to announce my routes only to an IXP and not to a particular transit provider. A couple of projects from RIPE that I found are super handy. One is the RIPE Atlas. I've got some scheduled measurements on there to get the chaos ID.server. So I can work out from various locations which Anycast node they're preferring. And I'm also using RIPE stats, using the API to check the visibility of my /48 anchor prefixes. So every 15 minutes, I call an API method for each of the /48s to check that those are still visible. I have a Google alert set for the VPS BGP session, and I often find companies come onto the market, they're offering them, and there's a couple on here. The first one is Portlane. These guys are based in Sweden, and they have listed on their website that they give you a BGP session for 10 euros a month on top of your VPS. The next one is Zetagrid. These folk are in Australia, and they actually have a web form where you can just put your prefix and your ASN in. I haven't bought the VPS from there because I thought they were a bit expensive because it came out at $27 a month, and that was nearly most of my budget. And I'm still intrigued if this BGP session form where you put the AS in the prefix in, if this actually sets up the session automatically or not, or if they do any sanity checking. I'd really like to hope that they did some sanity checking. There's a couple of interesting discoveries I found about Anycast on the way. It's super easy to find folk that are doing this on a budget because sometimes the ASs are registered to people's personal names. They're often found trawling the forums like I've done in the past. And there's a couple of interesting deployment mechanisms I've seen. Sometimes people will have a shared /24 where in all their locations they'll announce the same /24, and then people will have dedicated IPs on that /24 with custom reverse and forward DNS to make it look like each of those companies are operating their own Anycast service. The next one is a hosted /24 where maybe a web hosting company A takes out one of their allocation, their /24, and another company announces it on their infrastructure globally. So it's like a hosted service. And the next two are slightly more sketchy. There's maybe a company only has a single /24, but they announce it in all their locations, and they offer to their customers dedicated IPs that are GRE tunneled back to a single DNS server. There's a couple of companies that I can mention after this if people are interested that do this, and they sell it as a service for maybe $5 to $10 a month that they GRE tunnel you an Anycasted IP. And this gives the impression that you're offering Anycast, but it's got terrible performance. because your traffic is going into all the edge nodes, back down some GRE tunnels to a single location. The last one I find is quite entertaining is someone might only have a single /24, but they want to do Anycast, and they also want normal services. So they'll announce the /24 from their primary location, and then at all their edge locations, they'll also announce it, but GRE tunnel back IPs that aren't used for the Anycast service back to the first location. So I found not all DNS hosting companies actually host every zone at the edge. Some of them cache at the edge and actually host the files in a single location. Others will do the tunneling, so it looks like they've got services at the edge, but really they're central and everything's going back down a tunnel, and that means they don't have to increase the spec of their edge locations as they take on additional DNS zones. And there's these folk that are offering /32's GRE tunnels back. I thought about having a little try with HTTP because there seems to be the new rage with Cloudflare and the like doing this. So I set up a couple of host names that you could curl, and it will return some JSON to say which box you hit. And this made it life a little bit easier when folks said they had routing problems that I needed to investigate, because I could just get them to go to the URL or just curl the address and I get the JSON. So what next? I wanted to keep honest and keep hosting all my zones at the edge. I really need to actually have a web interface and not ask people to use curl to add their zones to the service. And as of this month, I've started experimenting with a healthy mix of DNS and routing daemons. So on a per node basis, I can specify if a box runs bind or NSD4, and if it uses Quagga or Bird, and then I can have a nice mix and I won't hit any problems with a single vendor at the edge. I'm still looking for friendly hosts in other locations. So as of today, this is all the locations where I'm live at the moment. We've got a European heavy instance, but there's some other locations coming up that I'm trying to spin up boxes to increase the performance in APAC, and Garab offered me a hosting location in Singapore when I met him at Sanog, and I'm just waiting to turn that box up now as well. One quirk with the network here, I found that the traffic was actually preferring my node in Warsaw in Poland. So after this, I need to look at that and work out what I need to do to get traffic to stay in the region. And this is currently costing me about $480 a year, so it's well within the budget, and I haven't had a divorce yet. So the takeaways from this is that BGP on a VM has got a super low barrier to entry now. There's no big turn-up fees. People will do it for $40 a year, which is super surprising, but also super scary, because you could get a box. You might not have good intentions when you buy that host. You could be using it to do a prefix, to maybe sabotage a prefix and advertise a prefix that isn't yours. So if you're offering BGP sessions for not much money, or if you're offering BGP sessions to your customers in general, always have IRR prefix list filters, and or get a LOA letter from them. Using Anycast can improve the service delivery to your customers as well. You can get these services much closer to the edge to increase performance. And as I found with this, one of the things, I invested that little bit of time at the beginning in writing some automation, and that's meant that I could turn the nodes up very quickly now. I just spin up a Debian box and install Puppet, and everything's live. And I'd encourage people to come and talk at conferences and share what they're up to. Are there any questions? I have one last point that I was meant to say. One thing I've found as well is that because I have a mix of providers at my edge, I don't really have optimal routing. And if you were to do this in a commercial environment, I'd suggest picking a couple of transit providers globally and using those, so you didn't have this doglegging and ballooning that I've seen on my network. Yeah.
Right. I'm Jichen from .lk domain registry. So this is something we've been looking at, but what we've been really scared of is BGP. So because running BGP with various unknown service providers is a bit scary.
It's very scary.
Right. So obviously you could afford to do it. It's your, it's your hobby project. If this is going to be scaled up to a production network like a TLD, top-level domain, what changes would be needed? And especially, I noticed just now the traceroute it goes to Poland, as you
Yeah.
said.
So
Uh,
if I was to do this on a commercial basis, like I said a minute ago, I picked 2 providers to announce the prefix globally from. And then any place I had a local box, I'd announce it with the BGP no export tag so that people didn't pass it on to their customers.
So basically, you would say just announce it locally to that ISP alone, and then have a couple of global things which.
Yeah, I'd take a contract out with a couple of providers globally, and
Right, and
pick
pay
it-
them probably more than $48, right?
yeah,
And I mean, that would make. I mean, we are not worried about $48. Yeah. Okay. So go for a couple of slightly higher-end connections, and then a whole lot of small
in multiple
boxes.
locations, but pick the same service providers globally or
Right.
in a region.
So you also said that there are people who have something like this commercially. Would it make sense for? I'm just thinking aloud. Sorry, for say. Well, I'm talking, of course, about TLD registry, but it could be anyone else, to sort of form some kind of consortium, or do what you call was sharing, but do it more in a commercial manner, so that we have a group of people all around the world who share resources with each other.
I've found a few people have got in touch with me and asked to do swaps of locations. But there's also organisations like I think Curtis is standing up at the back to talk about, and PCH that offer that service to TLDs. But then surprisingly, I've had 2 TLD operators email me and ask for me to host their zones. I also had a hosting company that I had a random email from them, and they asked if I could slave 10,000 zones for them within a week. I said I couldn't take 10,000 on straight away. I'd take 1,000 on and see how it went.
So my name is Yasuhiro Morishita.
Hello.
But call me Orange at JPRS, JP Registry. And so I have 2 comments. And so one is as you know, the NSD4 is so incremental zone increasing. And second comment, in Japan and some kinds of Asia countries, so is now receiving a silly DOS attack called random subdomain names DOS attack. So I feel that this simple and so easy Anycast technology can be applied at the authoritative mitigation strategies.
Yeah.
Right.
I think I've seen a lot of people using the Anycast to mitigate DOS attacks by getting many more boxes closer to the user so they can take the strain off the single large locations.
Yeah. Thank you.
Okay.
This is Gaurav from
Hello.
Limelight. Hi. Have you been on the receiving end of a DOS attack yet?
Not that I know of. I have set up some monitoring, but I haven't seen any large DOS attacks yet. I'm hosting about 30,000 domains, but I haven't seen any huge outages.
Do you think you'll be able to cope?
Maybe
If
the little box in India won't be able to cope, but some of the other locations have got a gig and are reasonably spec'd.
But not the small boxes,
I don't think so.
okay.
The Raspberry Pi certainly wouldn't be able to. But maybe in a single location I could deploy multiple Raspberry Pis and do equal cost multipath.
Okay, actually my answer was to Jichen as well. BGP is not hard.
No, it's super easy.
Dr. Philip just behind you.
Curtis Link is NetNode. So it runs run one of the root servers at Anycast, and we also provide Anycast for some 45 countries. To Gian's question, I think that there's a little bit of, if I was a CCTL registry, there's a little bit of a difference, because if you start sharing resources, it also means that you send your zone data to someone you have no control over what they will do with the data or how they will present it to the end users. You have no idea that the query sent to your zone is actually going to be the queries answered as you want them to be. And if I was a CCTL registry, I'd be pretty careful about that, because you really want to make sure you have zone consistency across the nodes when you answer that. That doesn't mean you should automatically be suspicious of your friends, but for a legal framework reason, maybe should be a bit careful, a bit cautious. As for the DDoS attacks, we see them more or less constantly. There's a lot of love out there. But I think there's a bit of interesting with the random DNS queries because not all of them are coming from the edge. They're actually coming from very central locations. I'm not so sure that having many Anycast nodes necessarily help you. It's more about where you have them than how many you have.
Yeah. Well, about security of the edge nodes, one thing I've started doing on the more recent nodes is when I get the VM from the provider, I have a crypto loopback file system on there, so that I have to manually unlock the file system when the VM comes up. So if someone was to stop the VM and clone the disk at the VPS provider, they wouldn't get access to all the configuration and the zones. I've been a bit skeptical about someone just pinching my boxes. Martin?
Martin Levy, Cloudflare. Not going to talk about my day job, but I like Anycast. I want to talk about this, because this is as good a chance as any to sort of match something you've said. I picked this up at NZNOG. It's a little access point with a built-in router with a full MikroTik 6.x or whatever the latest is OS in it, and it sure enough runs BGP. So in your light of doing BGP on the cheap, here is a $37 box that will do pretty much every IP protocol I can find. And the reason I left the cables on is because I wanted to explain that you can sit on a random airplane or a train, and you can plug in your Ethernet and USB for power, and then connect to it over Wi-Fi or the Ethernet, and there's your BGP play tool with just about every feature I can find that the MikroTik has. Done, finished. Oh, I should turn this off because it's got Wi-Fi enabled. Sorry. But the point is that you've shown, and I want to just discuss the BGP part, you've shown that you can do BGP for a very low cost. You've also shown some of the frailty filtering. But this should be encouraged. The BGP at low cost should be encouraged. The filtering should be explicitly explained to these users. And we should do as much as possible to make this useful, not only for your application, but potentially for other applications out there as well. We've gone the route of this low-end hosting, and there's no getting back from that whatsoever. No. So I just wanted to randomly share this. It's been my funnest toy that I've picked up, and it does work.
Cool.
Andrei Rubachevsky, Internet Society. Well, thank you for this excellent presentation. I have a question with regards to education of the VPS providers with regards to BGP and filtering. So were they receptive to your suggestions? Did they implement prefix filtering?
Yeah, most people did. A couple of people, after I brought the box up and I was announced the prefix, I'd always wait 2 or 3 days and I'd turn the VPS off to have a look and see if their border routers were still announcing the route because they saw the route coming in from their transit. And if that happened, then I had a template email that I sent them and said, hey, I noticed that you shouldn't still be announcing my prefixes because you see it from your transit rather than internally. And in most cases, I'd point them at some presentation I'd seen at events about best practices on how to configure routers, like the BGP 101 talks and stuff. And they'd have a go at them, and then other cases, maybe it was a week later and they were still getting it wrong. And then I'd offer to SSH in and we'd share a TMUX session and I'd configure it for them. But in a lot of cases, they configured their box after reading forums in the first place, their edge router. They hadn't had any other BGP sessions, maybe them from one provider.
Did you ever check that they implemented spoofing measures?
Sorry?
Source IP address spoofing, anti-spoofing measures, like
not many people
ingress filtering. Have you checked?
A couple of people whose boxes I had access to, I configured it, but in most cases, the people aren't doing that. Not at this level where they're maybe buying a MikroTik router or they're routing on a Quagga box or something in front of their VPSs. Cool.
Thank you.
Thank you.
So any other question, comment? If not, thanks, Nat.
Thank you.
This is the end of the Apops 2. We have a lightning talk on this Thursday, and the CFP is open already. So if you have something to share with the participant, so please submit your slides or abstract to at the submission@apnic.net. Correct? Yes, please. Okay, let's have coffee break.